Good morning, Ignite students. Here we go. It is Mineral Properties Day. All right, here we go. What are the properties that distinguish one mineral from another, and how in the world do you identify all the different minerals that are out there? Here we go. We're going to think about the major ones. We got color, streak, luster, crystal form, hardness, um, cleavage and fracture and density. Those are the ones we're going to think about. Those are the ones we're going to focus on. I know this website says mineralogy for kids. Well, we're all still kids somewhat. This is not bad. This is not bad at all. If you want to start, is it metallic or non-metallic? Well, if it's a metallic mineral, look, determine the hardness of your mineral. See if it scratches something. Ooh, if it scratches something, then it's one of these two. What if it didn't? Then it's one of these couple right here. So you go back. If it's a non-metallic memory, you can answer these, and it narrows and goes through these branches. It's not a bad little way to start deciding. You may want to. I may reference this again for you before you do the assignment. You've got an actual assignment and work today. So first thing that's up, color. Color is the first thing you notice. It's one of the first things you see. It's obvious, and it's probably the least helpful. Color doesn't tell you a lot because this is what a ruby looks like in nature. That might be a sapphire as you dig it out of the ground before you polish all these up. Those are both corundums. That's all they are. They are the same mineral, okay? Here's the difference. Ruby is the red version of it. Sapphire is every other color of it. Even though we think of it as blue, any of the other colors of corundum are also sapphires. So if I said, hey, we're going to go look for this blue thing, and you find this one, you throw it out back and ignore it, you found the corundum. You just didn't find the sapphire version. You found the ruby version. Small amounts of impurity can take some of these clear or minerals and really color them and affect what's going on. Okay. Fluorite. Fluorite comes in all of these colors, like all of them. Usually purple is a good indicator that it's fluorite, but it can be a yellow and a brown, but this green and teal, it's all of these. That's what fluorite is. That was that one. Okay. The streak plate. What you do is you grab a piece of porcelain, not glazed. You take the mineral and you drag it across the top. You see what color streak it does. Some things leave no streak. First of all, some things leave no streak. Others will leave a dark streak or a white streak. I know I said color is not that useful. Color of the bulk mineral. Is it gray or is it pink? I don't know. Color of the bulk mineral is not that useful. The color of the streak can be very descriptive. It can narrow things down quickly. All right. So this will powder the mineral. You just want to see what it does. All right. Luster. Luster is shininess. Okay. The big thing with luster, is it metallic or is it not metallic? Meaning, is it reflective? Is it shiny? Or is it not? So there's metallic. This is a fancy example. There are better examples of this. This is also metallic. Let me try and get some light reflect off that for you. All right. We'll talk about this in a minute. This is galena. All right. Metallic, you got luster. Submetallic means, yeah, it's kind of that way. Other descriptions of luster, these are not numbers. They're not quantitative. They are qualitative. Okay? So, adamantine, or sometimes brilliant, is diamond-like, right? Resinous. So that looks kind of like a hardened resin or old wood glue, right? Glassy, pearly, greasy, silky, dull, earthy. Those are luster. Honestly, is it metallic or non-metallic? right? Then the non-metallics can be broken down to dull or glassy or pearly. Those can be broken down better, but metallic and non-metallic is the big dividing. Okay. After luster, crystal form. Here's a crystal. You look at that and you say, that's not a crystal. That's just a funky rock. Crystals, what you think of when you hear crystals, might be things like this, right there. Those are crystals. There's some quartz crystals in there and all sorts of other stuff. There we go. That's what you think of when you think of crystals. This is also crystalline. The crystals were in a small space and they formed really small groups. So if a mineral forms where it's compressed and where it's tight in, the crystals take a different shape than if there's room and free room for them to grow. Crystal growth is a very slow process. Crystal growth and the crystal structure of the mineral is not the same as the way a mineral breaks. If a mineral breaks clean on a side, we're going to talk about that in a minute, that does not mean it has a specific crystal structure. Those are separate properties of the mineral. Okay. Woo! I'm going to need this Thanksgiving break. Sorry about that. All right. Yep. We got that. So here are different ways these crystals can grow and look. These are fancy names. We are not going to worry about classifying these, that this is almost hexagonal and you've got hexagonal here where you can actually count like 6 sides around there. All right. We are not worried about the different names of these crystals or how they form. They're just properties of the mineral. Okay. Here we go. Mohs hardness scale. Okay. This is probably the most useful test. First of all, it's one of the few that's numeric. It's quantitative. You can put a number with this. Yes, it orders things, but there are specific numbers that go along with this. 1 through 10 is the Mohs scale. 1 through 10 is the Mohs scale. Talc, gypsum, calcite, fluorite, apatite. Orthoclast, quartz, topaz, corundum. Remember, that was the ruby and the sapphire, and then diamond. These are in between. All right, steel nail, knife, copper penny, fingernail. So if you could take your fingernail and scratch a rock, then that rock has to be softer than your fingernail. So it's a 2 or a 1. Conversely, if you take a rock and it scratches the back of your fingernail, then the rock is mineral, not rock. The mineral is harder than your fingernail and it would be above this. If they scratch each other, they're the same. That's how we use this test. If we were in person, this would be a lab. You would do all of this stuff. There would be a streak plate and you would rub it across there, and there would be a hardness test, and there'd be a penny and a fingernail and a nail, right? And you would test all of these. Okay. I want to show you one other thing. The Mohs is not the only scale. The Mohs is the most common. The Mohs is the one you need to know. But this is the Knopp scale. And I just want to show you that 1 through 10 is not necessarily evenly spaced. To go from a 10 to a 9 is a huge step down. And to go from a 6 to a 5 is a medium step. And to go from a 2 to a 1 is not that big a step. The Knopp scale, what they do is they put a sample and then they get essentially a diamond and they press down in it and they bring it up and they measure the indentation. And so this scale tells you what that is. The Mohs scale is the most common. It's the one everybody uses. But it's not the only one, because to say that, oh, I went one step from a 7 to an 8, so it got a little harder. No. Going from a 1 to a 2 is a little harder. Going from a 7 to an 8 is a lot harder, and a 9 to a 10 is even more, right? So every step up here is a bigger step than a step down here. That's all. Just wanted to show you, mention that there is another scale, just so you can see what else there's out there. Awesome. All right. That was hardness. Now, cleavage. Cleavage is how a mineral breaks. Okay? It's the tendency of a mineral to cleave or cleanly break along a specific flat surface. Okay? This is not a polished rock. When we say cleave, here are examples of minerals that cleave. You hit them and they break. Like I said, this is a specific example of galena. So is this, all right? So you can see all those little cubes running around. The lighting's not great. It's not very reflective right now, okay? Here. We're going to watch a video because we can. When you hit this halite salt with a hammer, here it comes down, it's going to cleave and break in a clean straight line. There's not jaggedness everywhere. All right. Promise it's... I did pause. Go away with that tab. Bring that one up. Here we go. Hit it with a hammer. Wham. Now you see some clouding and some fracturing, but then all of the energy went wham. That is a very straight line there. This side, there's a straight line there. The bottom did get jagged and the piece broke out. But can you imagine how many atoms are lined up across there? And every single one of them, they said, whoom, at the exact same way. Atoms are bonded. This is sodium and chlorine. And they're all bonded and they're lined up in a specific order because that's what makes them crystals. And the crystals are strong in one direction and not the other. And when you hit it, it will break along specific lines. That's what cleavage is, and it's actually kind of cool. All right, here we go. So halites, the salts, the calcites. So you can cleave them in 3 directions. 3 directions. 1 direction for gypsum. So these are other things. That's the muscovite. Okay. Quartz does not cleave. Quartz fractures. Fracture is the opposite of cleavage, meaning if you hit this, it's just going to go apart in randomness. It's going to be uneven. It's not going to be smooth. There's not going to be a clean line. All right, let's try this right here.
It may be as simple as the mineral peeling into thin, flat sheets, as this one does here.
Check that out.
This is a sample of mica. And it exhibits cleavage in one direction.
Look how thin that is. You can see through it.
Peels off into very thin, smooth, flat sheets. That is just another example of cleavage.
He's got one more here. Let's fast forward for a second.
I'm just going to tap it lightly with this hammer and see how it breaks.
Look how straight those lines are.
Here are the pieces that broke off. They still have smooth, flat surfaces. They were not cut. It was not done in any gentle way.
Okay.
So that would be an example of cleavage.
There you go. Now, same. Here we go.
You'll notice that many times rocks just break in jagged and uneven
We're going to look at fracture now. Okay. Fracture.
Other times they may break in unique ways, according to the structure of the rock or mineral. This is usually referred to as fracture.
So it's uneven, and it depends on what's inside there. Now,
occasionally, rocks or minerals will break in smooth, even splits. This is known as cleavage. When a mineral is cleaved, we can see smooth, flat sides, known as facets.
Is galena.
Let's take a look at some of the distinct types of fracture and cleavage. One unique.
Okay, that was fine. Oh, actually, this is interesting. You'll never see this in your life, probably. Maybe if you become a geologist.
Of mineral fracture can be easily seen in this sample of asbestos.
What?
In this silky lustered sample, we can see that the mineral breaks in these small soft fibers. These fibers were quite useful. Because of their insulative properties, as well as being fireproof, they could be woven into a fire-resistant material. This was used quite a bit until it was discovered that inhaling the mineral fibers could lead to cancer and other lung disorders, so it's no longer used today.
Okay, I just want to show you that that's what asbestos actually looks like, and if it's fibrous, I cannot believe that. I'm sure the person in the video has on a respirator, because that is going to give somebody cancer right there if you inhale any of that as it fiber. So cleavage and fracture are the specific ways that these things break. Okay? So cleavage is the nice clean lines. This is a specific type where it's fibrous. And then there's flat planes, like the mica that you just saw. There's clean lines, like the halite, the calcite, the galena, all of those. These are the properties of minerals. There's all sorts of stuff going on. Minerals are cool. We're going to talk more about them. We're going to identify them. There is an assignment. I want you guys to work on the assignment. Have a great Thanksgiving. Be safe out there. All right? We'll see you later.